Welcome to another episode of the AppSec Insiders Podcast. This is a show where we discuss the hottest topics and latest trends in application and cloud security and tell you what you need to know. For those who don't know who we are, we're all software developers, white hat hackers, and code security experts. And when we're not recording this podcast, we help organizations of all sizes with their cybersecurity needs. If you're an AppSec professional looking for an opportunity to work with some of the best in the industry or a developer with an interest in cybersecurity, be sure to check out our careers page at forwardsecurity.com/careers. We would also greatly appreciate it if you would subscribe to the podcast wherever you listen to the show, and be sure to follow us on LinkedIn and Twitter, @forwardsecurity. Links are in the show notes. And in today's episode, we will be discussing CICD security. Specifically, why are attackers focused on the CICD pipeline? And we'll also be talking about the security risks inherent with CICD pipelines. Joined with me today, I've got, as ever, my co-host, Iman. Say hi.
Hi, Iman.
We've also got, live from the RSA conference, we've got Farshad.
Hey, everybody. How's it going?
Hey, how's the conference going over there?
Pretty crazy. I heard it's twice as many people as last year. I mean, I don't know if the numbers are correct, but someone told me 60,000. Last year was 30. That may not be correct, but there are definitely a lot of people, and I can feel it in the room.
Wow, that's huge. And also with us is Jordan.
Hi there. Excited to be here.
The masked podcaster. So how shall we kick this off today? I think we should probably start with, let's talk about why even this, maybe for a high level, let's give a brief description of what a CI/CD pipeline is. I'm sure a lot of listeners maybe already know what it is, but maybe we'll give a really well-defined set of criteria for what makes a CI/CD pipeline. It's not just, taking your app from development to deployment, but there's a particular thing that defines what a CI/CD pipeline is. I'm going to take a little crack at it, and then you guys, if you want, please add to that description. So I'm going to go ahead and say that a CI/CD pipeline is one where you take the build of your app. So in development, you'll have, you're using version control, and you'll have check-ins. And whenever you check in or push, or even sometimes when you commit, there's some automation which happens in what's called a pipeline, which is just another computer somewhere, another agent that pulls in the code that you've checked in or pushed, runs some series of processes on it, usually for the CI part, the continuous integration part of CI/CD. We're talking about linting, looking for bugs. For security in particular, we're talking about looking for security issues with the code that you've checked in. That can be vulnerable dependencies and libraries or possible vulnerabilities in your code. And then when your code is ready for deployment, we move on to the deployment side, the CD part of the pipeline, which is when you go to deploy. During the build process, it does another scan like that, but also you can add in things like a DAST scanner, dynamic scanner, which is where it will fire up a sort of a dummy version of your site and use a dynamic scanner to search through all the endpoints for potential vulnerabilities and provide reports. And there's lots of things that we can talk about in terms of DevSecOps. One of them is which security scanners are you implementing, and where are you implementing them, and how are they configured and tuned and all that stuff. And then there's the other side of it, which is the actual configuration of your pipeline. Where are your secrets in your pipeline stored, and who has access to the secrets in your pipeline, and who has the ability to run that pipeline? Not to mention also how your code gets deployed into production. Are you using SSH? Is there some internal process that runs it through? How much human interaction is required? So that when I picture CI/CD pipeline security, DevSecOps, those are all the things that I'm thinking about, and that's the best way that I can describe it. Does anybody have any kind of addition to that or amendment? Maybe I've forgotten something.
I want to say that CIC systems, they have revolutionized the software development landscape with diverse technical stacks and quicker adoption of languages and frameworks, and increased automation and reliance on third parties. There are more risks to CIC pipeline, and this increased flexibility and diversity in software delivery have created some new attack surfaces, such as the high-profile incidents that we had, such as the SolarWinds, which demonstrates the growing focus of the attackers on exploiting CI/CD ecosystems. Also, security teams that are struggling to find the right balance between engineering agility and optimal security as they work to detect, understand, and manage CI/CD related risks. There is a very nice framework called OWASP Top 10 CI/CD security risks that I would suggest everyone to look at that. And today, actually, we're going to mention a few items from that framework. I want to know, like, Farshad's opinion specifically on the risk around the CI/CD security.
Thanks, Manjan. Yeah, and actually, before we go into security, I just want to add a bit more context in terms of where this all came from, right? Because back in the day when you do development, it was all manual build and deployment, right? Some companies had make systems and try to automate the build and all that sort of stuff. But then in the early 2000s, the CI/CD came about, and the idea was to automate the building and the deployment of that. And then agile, that's a key component of agile development. So as software companies went from waterfall to agile, one of the key requirements of agile is to be able to automatically build and deploy. And so the intention was that as soon as a developer, checks in some code, a bunch of automation is ran, and focus was not on security, right? Like the idea was just that you automate. Someone is checking some code, you want to build all this stuff and take all your different components and then create that build artifact and then put it into a repository. And then when the build was done on the CI side, you would have the CD side of the game where the CD would deploy the built artifacts into an environment. So that's how CI/CD came about. And then when DevOps came, like when Agile moved on to be DevOps, they further built on the components of Agile, one of them being CI/CD, and added additional things by bringing the operational team to the game as well. So the focus on the CD part of the game increased, whereas things would be deployed into either a staging environment or into a production environment. So that it's interesting because the CD definition could either be continuous delivery or continuous deployment, depending on who you talk to. So in companies that don't deploy to production, the CD is continuous delivery. However, in companies that deploy to production, the D part becomes continuous deployment. So there's all these nuances that are really important. And then when DevSecOps came, the DevSecOps is like, well, you got DevOps, but the security is missing. So let's add security. Let's add the sec into this whole game. And then let's look at what we're doing on the integration part or on the CI and what kind of security can we add there. And as Jared mentioned, you can add a lot of static analysis on the CI part because you're building code and it's all static. And of course, you can't do any dynamic analysis. But on the CD side, where you're pushing the built artifact into deployment, that's where you can perform the dynamic analysis. Now, having said these kinds of things is that oftentimes developers don't incorporate security into the CD directly, because if you put it as a blocker, dynamic security often takes a long time. So often the security that's deployed on the CD side is done as a parallel build rather than something that you put in a sequence of actions. But that's sort of the history and where we've come from. And and it's really important to make sure that the right security gates are put at the right place in the CI/CD pipeline. But yeah, we should definitely talk about the OWASP top 10 CI/CD security risks, and maybe we can start with some of the easier low-hanging fruit on that list. Maybe the first one we can talk about. I believe the insufficient flow control. Yeah, Imanjan, do you want to?
Exactly. Insufficient flow control mechanism. Actually, it highlights the risk of attackers pushing malicious codes or artifacts through CI/CD pipeline without proper approval or review. And insufficient flow control mechanism can be abused by attackers to deploy malicious artifacts in production without being detected. Also, establishing pipeline flow control mechanisms will help us to prevent single entities from shipping sensitive code without external verification. And we should always require additional, I believe we should always require additional approval or review before triggering the production build and deployment pipeline. And we should always limit and review auto-merge rules to prevent bypassing and avoid using third-party codes in the process. Like, for example, I've seen the people put Dependabot or some other stuff in auto-merge, and sometimes this could pose some dangers to the pipeline. And also we should configure some branch protection rules for branches hosting a production or sensitive code. and also there are some artifact that we should allow artifacts to flow through the pipeline only if created by pre-approved CI service accounts, and not all accounts should be able to do that. And also we should have a mechanism to detect and prevent drifts from production code and its CICD origin, and detect those changes, I believe. And this is one of the low-hanging fruit. And as we can see, we can develop some tools not to automate the detection, but to augment people ability to audit the CI/CD pipeline to find the issues, actually. And Jordan, also, what do you think about?
Yeah, for sure. This one's really important, because what's really interesting about this is you've got your source control management system, which could be GitLab, GitHub, etc. And a lot of these tie your CI/CD pipeline configuration as code in that in the repository. So you might have like a Jenkins file, you might have a GitLab CI YAML file, or it's GitHub Actions YAML files in the GitHub .github workflows folder. I think there's also a Circle CI file. Most of them are managed through YAML or some sort of configuration file in some way. And the reason I mention that is because what you can actually do is you can push, you can add malicious code to the pipeline itself if you're not properly managing how code is pushed into the repository. So if we've got insufficient flow control here, I'm thinking like, you might not be managing that with pull requests or what have you. And so I can actually introduce malicious code into the pipeline itself through that insufficient flow control mechanism.
So how would somebody who is a DevOps manager, how are they, or DevOps engineer, whatever they call themselves these days, how are they preventing something like this?
Well, at a high level, the lowest hanging fruit, the biggest problem is that I see that they create a pipeline. For example, one client, not to be named, had a pipeline that if he had access to it, he could push right into production, right? And everyone in the team, all the developers, had access to that pipeline. That's not appropriate. If your pipeline results in pushing something to the production, there should be one person in that team that has access to do that, and that should be audited and logged, right? Because if everyone can push to production, imagine if one developer's account gets compromised, then the attacker can leverage that and be able to pivot and deploy something to production. So this is where it's really important to review particularly on the CD side, to review who has access to it and minimize the people that have access to it, and really enforce that level of control.
Right. So so you're suggesting really we need a separation of roles. There
Absolutely.
should be people who are in control of CI. I mean, you need your developers to be able to push and to make pull requests. And the way I've seen it split up is you have all developers can make pull requests. Then you have some higher level developers who can merge those into the production branches. And then you have a very small set of people who are capable of deploying.
Exactly.
Yeah.
And then in a lot of small companies, they're small, right? And I mean, you guys can all agree. We talk to clients and they're like, hey, we're really small. We don't have that ability to separate these concerns. I only have one person that's building this, or two people. And the answer is, well, that's okay. Initially, at least design the roles, right? As Jared, in your example, there's 3 roles, right? Like the dev, the person that approves the merge, and then the third one for deployment. At least do your role design. In the beginning, maybe everyone was wearing all 3 hats, but at least you've designed it so as your team grows, people can take those hats off, and then you will have different individuals performing that, right? It's always really important to act by design and kind of say, oh, this is where we want to get to, but today there's only one guy that's doing all 3 things, right? But then eventually we'll get to a point where those would be separate people because we're a bigger company, and then there's a separation of duties.
Right. And I think it's important to add that why is this even an issue? It's really when your company has a lot of developers, right? If you only have a few people working on your team, this doesn't, there's fewer targets for attack of, for their computers to be compromised and have the pipelines take over. And there's fewer chances that a developer will do something either maliciously or accidentally. But as those numbers grow, this becomes a greater problem.
For sure. And maybe this is a good segue into the next item, but I just want to say, going through this list of OWASP top 10, CICD issues. A lot of this, to me, it looks like common sense. Like insufficient control mechanism. The next one we're going to talk about is inadequate identity and access management. A lot of these, you would think are like pretty standard IT sort of security issues or controls that need to be implemented.
For sure, and that's why we have this checklist so that you're thinking about your code, you're thinking about your customers, you're thinking about your finances, especially when you're a small company. You're not thinking about all the minutia, even if they may be obvious when you focus on that one thing. And so it's good to have a list like this to help help you not have to it allows you to not miss anything.
Totally.
So did you want to talk about identity and access management?
Sure. Let's touch on that one quick. Yeah. I mean, I think we've sort of touched on it already.
It is sort of self-explanatory.
Yeah, like overly permissive identities. What else do we talk about here? Just
shared accounts, probably.
Yeah, absolutely. Shared accounts, shared keys, things like that.
There are some stale accounts. I believe we should continuously analyze and map identities across all the systems.
Mm-hmm.
And we should remove unnecessary permissions and disable remove stale accounts. There are some accounts like for 6 months, no one has logged into that account. And also we should use centralized identity management using an IDP. And by anyhow, we should avoid using local accounts. And also, sometimes even us, we are consultants. We start an engagement, and we have some customers. They add us into the CIC pipeline or GitHub or anywhere like that, and they forgot to offboard us after we finish the engagement. And we always should send an email to them, please offload us. We should always carefully manage external collaborators and ensure their permissions align with the principle of least privilege. And that is very important. And we should prevent employees from using non-organization email addresses. And also, I've seen some attacks on like high-profile websites that the self-registration was on under GitLab. And the attacker was able to register like a low privilege user and read all their codes, actually.
Oh, wow.
And we should restrict self-registration and base permissions for users too, actually.
And the shared identities is the other culprit, right? Sometimes they just have a shared identity that's used either by humans or by the other tools that connect to the pipelines. I think maybe on that note, do we want to talk? There is one that's talking about ungoverned users or third-party services. Do we want to talk about that, or do we want to talk about dependency chain abuse?
Dependency chain abuse, I believe, is interesting because you remember in 2021, one guy has hacked like Microsoft, PayPal, and like a bunch of other high-profile websites. And dependency chain abuse risk arise from flaws in how engineering workstations and build environment fetch code dependency, which can result in malicious packages being inadvertently fetched and executed. The top thing that I've seen was in 2021 via dependency confusion, which is actually is a software supply chain attack that substitutes the malicious third-party code for legitimate internal software dependency. The solution was the mitigation was easy. If you define your scope and you use your private package, when you want to use your private packages, they cannot attack you because they don't have access to your scope. For example, in the npm, but there are a bunch of other attack vectors such as typo squatting or brand jacking. People, they start to create packages similar to your company's packages in npm with misspelling the package name, and the developer starts to code and they add the package, but the malicious package would be fetched. This is an interesting attack vector, I believe. In general, I love that dependency confusion idea. Yeah, Pastor, what do you think?
Yeah, no, I agree with that. Dependency confusion has become a problem. All those things are true. There's also dependency hijacking, typo squatting, brand jacking, all those kinds of things that are the main attack vectors in this situation.
Yeah. Yeah.
So what would we say is a good control against dependency confusion? Like one I can think of is if you have your own internal repository, like an Artifactory.
I was going to say, Jordan, that's one of the ones that we implemented at the bank. It was like, hey, don't pull any dependencies from the wild, right? Like everything should be pulled in from our artifact repository. It's a difficult one, right? Because then developers are like, wow, it's a lot of work. But yes, you got to balance it with security. I mean, if you're just going and grabbing any package from wherever source without having vetted them, then you could be getting into trouble. So yeah, and again, it's one of those things where if you're a small company, it's a lot of work for you. Like I'm setting up an artifact repository and all that kind of stuff. It's a lot of work, but we have worked with small companies that have done that successfully. Jared, one client you and I worked on comes to mind. The very small client, but they still had they were using Nexus as an artifact repository, and it worked really well for them. But it's also important to note that just because you use a artifact repository and you're not pulling packages from wherever you want, that doesn't solve your problem. You should do some vetting or security analysis, right? So just because you moved it from the internet to your artifact repository doesn't automatically give you that additional security.
But
okay, go ahead.
I believe the easiest solution is to define your own namespace and claim that. For example, I'm talking about npm, and after that, even like no one can create like a new package under your namespace. And also, we should enable checksum verification and signature verification for the pool packages. Like SRI, we have sub-resource integrity, we compute the hash, and we should kind of have that hash in place to check the checksum, actually. Good.
So sub-resource integrity, you also touched on dependency confusion there, which is a good thing to mention.
Yeah.
Which is why you should claim your own name. It's interesting about NPM. Now, NPM has done a lot for developers by adding the NPM audit feature, which actually runs automatically now when you install.
The thing is that it only finds vulnerable packages. It doesn't find any like suspicious stuff such as dependency confusion. Actually,
right. That's a good point. And the other thing I wanted to add to that is that NPM is interesting in that when you pull a node module, you're not pulling a self-contained library. You're pulling a library that usually has lots of other dependencies, and those node modules get pulled in. And those may have dependencies, and those node modules get pulled in. And by installing one package, you can often inadvertently install 200 packages, right? And so as a result, some of those packages that you've installed and some of their transient dependencies may rely on older, outdated, and known vulnerable versions of NPM packages. So, and NPM is a particularly tough customer when it comes to protecting against vulnerable packages. Not to say that there aren't vulnerabilities found in Java packages. We all know about log4j, but those packages are self-contained. So if you update it to a later version, you're more or less guaranteed that there are no publicly known vulnerabilities in any kind of transient dependencies. Yeah. What else? I think we might have to start wrapping up soon. Let me just take a look at the list here. I think there may be dependency chain abuse. We've talked a little bit about poison pipeline execution.
Poison pipeline execution. I don't think we can stop the podcast without talking about that one.
Absolutely,
So poison pipeline execution, you're basically modifying the pipeline in some way. You could be introducing malware. You could be introducing malicious code. Probably one of the most famous poison pipeline execution attacks would be SolarWinds, right? For those who don't know, they also call it a supply chain attack, but basically what was purported to be a nation state introduced malicious code into the SolarWinds Orion software. It's software that's used by a number of organizations, especially government ones. And this attack, I think it affected about 18,000 customers. So it was a pretty huge attack. And because some of those were government organizations, it appeared on the news. maybe let's talk a bit about what that looked like. So that breaking down, there are a few different parts of the attack. I think somehow they got access through an insufficient flow control mechanism to the pipeline. But what the attackers did was they introduced Sunspot, which is this. That's the code that injected this Sunburst malware into their software. I believe it's like C# or .NET app. Basically, when Sunspot finds this Orion solution file path when MS Build is running, it replaces a source code file in the solution directory with a malicious variant to inject Sunburst while Orion is being built. And so what was interesting about this one is they actually do have code signing, or build signing after the build is completed. But this sort of bypassed that because they were signing a malicious build. So this one was particularly interesting. And if we have time, we should talk about some of the controls that can be implemented for that, because it's a particularly difficult one. There are a few tools out on the market now. There's Harden Runner, which is an open source tool, which is trying to help with that for GitHub Actions. But Farshad, you want to comment on this one?
Yes, I just wanted to tell our audience about the nuances between the two. So in the first one that we talked about with respect to the flow control, that's where the attacker actually accesses the pipeline. So it's either a malicious developer or someone who's compromised that developer who can actually run the pipeline. So the focus is on actual running the pipeline. With the poison pipeline execution, the attacker doesn't have actual access to run that pipeline, but they actually have access to the source control system where the code for that pipeline or the configuration is stored. And that's an important nuance. So in that case, I can't run the pipeline, but I have access to the code of the pipeline. So what I go and I poison that code. So I inject malicious commands. And then when someone runs the pipeline, I couldn't run it, but the good developer is going to run it, but I've now poisoned that pipeline. So when they run it, that poison configuration will get executed and essentially do bad things. So I just wanted the audience to be aware of the nuances between the two.
Absolutely. That's a very good point. Yeah. Because you can introduce, even though you don't have access to the code itself, you can still potentially introduce like pretty malicious code into for example, the GitHub workflow file. So yeah, it's a very good point.
Yeah, exactly. Because a lot of these pipelines are just YAML files, right? Like even Azure DevOps, all they're just a YAML file stored in a source control system somewhere. So I just go and modify that YAML file. I can't run the pipeline, but when the developer runs it, it'll run my modified pipeline with that bad configuration. So then that pipeline can go and fetch things from the outside and do a bunch of things without me actually running it. But inherently, when it does run, it'll do the changes that I've introduced to that YAML file for that pipeline itself.
The next series of them, we have sort of touched on previously just because they're related. So for instance, insufficient pipeline-based access control. This is, who is allowed to do what in the pipeline.
But did we go deep into PPE?
That's what, yeah, so Farsha was just mentioning, if you can overwrite the configuration files, which are often just YAML files in your repo.
Yeah,
you can poison the pipeline.
But there are three kinds of PPE: the direct PPE, indirect PPE, and public PPE.
Oh yeah, please enlighten us.
Those are good nuance. Yeah, please, let's talk about that.
Yeah, for direct PPE, like exactly, the attacker can modify the CI config file. Usually that's the YAML file. And for indirect PPE, sometimes the YAML file that we are using or any like the pipeline file, they're using some resources that are not in our repo, but the attacker has the ability to change those resources. And instead of modifying our pipeline file directly, they modify the other resource, and then they can inject their commands into the pipeline. Also, there's another thing called public PPE, which attackers with no access to repository can still poison public CI pipelines by submitting unreviewed code as pull requests. And that's another one. But, in general, PPE attacks can lead to a wide array of malicious operations. And this is kind of something that we should take care about. And yeah, Jared, you were talking about insufficient PBAC, pipeline-based access controls. Please go ahead.
There's 10 items on this list. Right, it's the OWASP top 10. So if you didn't know, following along at home, we are going through from top to bottom the OWASP top 10. I don't think we're going to make it all the way through before the end of this podcast, which is great because we'll get to make a whole second episode out of the second
two, yes.
But I will go on to say that number 5, insufficient PBAC. You may have heard of RBAC, role-based access control. Well, this is pipeline-based access control. We've pretty much covered this because it's related tangentially to like the number 1, insufficient flow control mechanisms, also the inadequate identity and access management, inadequate IAM. It's related. They're all tied together. It's interesting that this one comes down number 5. I guess they really want to break things out in this list, but I don't know if we need to spend too much time on this, except to say number 5 is make sure everyone has their own discrete roles. But
this is talking about the containers that are running inside the CI, because the container should not have, like, the first category was talking about the people, but now this is talking about the containers. They should not have like unlimited access to everything, like all the repos, because if anyone has access to that container,
the build agent,
that the build agent is better.
It's funny they use the term pipeline execution node. I haven't heard that term. The term that I've heard commonly is build agent, but I guess they're calling it
the nodes actually. And we should avoid using shared nodes for pipelines with different sensitive levels or resource access requirement. Also, we should scope secrets to allow each pipeline and step access to only the necessary secret. That's the other issue. Like, for example, like different nodes should have access to different secrets, and it shouldn't be the case that one node has access to all secrets. And we should follow the the least permission thing that we have.
Privilege of least. I noticed that a lot of these problems, not all of them certainly, but a lot of these problems presented by issues with build agents, like whether or not they're patched, what artifacts are left on them. These can often be solved by having your build agent run as like an Azure function or some stateless, what do they call those? Serverless machines. So if you can have your build agent in a Docker container and have a server spin up only for the time that this pipeline is in action, especially if you can use serverless, because then the OS patching is taken care of for you.
And still restricting his access though, right? Because even if it's serverless, if it has access to your storage.
No. I'm just saying this solves some of the problems, not all of them, but for sure, you still want to make sure. Yeah, of course. Only some people should have access to this, to configure this machine. This machine itself should only have access to a very limited subset of things, including where to put the artifacts and where to, how to receive calls from the pipeline, and that's basically it.
Totally. And that's what happened with the Capital One attack. I mean, it wasn't around CICD, but the machine that they compromised had access to all their S3 buckets and everything else, right? Imagine you have a build agent that you haven't restricted it, and that build agent runs malicious code. Now it can go and access everything in your cloud environment or where that environment may be. If you're on-prem too, you should limit access so that they can't pivot. It's all about pivoting, right? The attackers want to get somewhere, land somewhere, and expand. So if you limit where they can pivot to through access control and other mechanisms, then you're winning.
Yeah, and if your build agent is stateless, you basically can't persist in there. So
exactly, takes away the persistence. Exactly.
Also, I've seen this issue in numerous clients that they don't patch the execution nodes appropriately, and they don't follow the network segmentation, and all the execution nodes, they have full access to the internet with no egress rules. They can initiate any connection, and that's the other issue that I see. Like, and they're not hardening the nodes, and these are the important stuff that we need to actually follow up and find all the issues, and like harden the nodes, patch the nodes, have the proper network segmentation, have the proper firewall rules. And I believe the next one that we want to talk about is insufficient credential hygiene. This is too wordy. Like the titles, when we see this, this is like not putting secrets, not handling secrets properly.
That was just funny because, even with us, with all of our experience, when I first saw this, some of the titles are very wordy, and I was like, what is this? And then once I started reading it, I'm like, oh, these are all simple things. So I think one improvement that could be done to this is making the titles a bit less wordy. Even the use of like pipeline execution note. I was like, what the heck is that? And I'm like, oh, build agent. So I think that could be something. That
but
could be
this category is pretty classic. Like, and it's interesting that I was watching a TikTok video. The guy was a developer, and he was very frustrated. He told that I pushed the secret wrongly in the GitHub repo 5 minutes after that. I found that the attacker got the key and they spin up like an instance, and in an hour the bill was $15,000.
Oh,
The AWS bill was $15,000.
Wow.
And he was telling on the TikTok, I'm not gonna pay this to the AWS. And
is there any recourse when something like that happens? Can you tell AWS, oh, we got hacked? And
yeah, I mean, I don't believe so. They don't accept it.
They try, like I was talking to our AWS rep. They do sometimes make provision. They do an investigation. If it wasn't fully your fault, it's on a case by case basis. But I know that when we partnered with them, one of the things they said, hey, we have a lot of clients that are getting compromised. So we'd love for you guys to work with us so that you can educate our clients so that we could reduce the fraud rate, and then that'll help the clients and as well as the AWS. But it is a problem. It is a big problem.
Yeah. All right. Well, we've reached the halfway point, and then the rest of them, I'm just going to list them out, and we'll talk about these in the next episode. But starting at number 6. Insufficient credential hygiene. So this would be, I suppose, how you store your credentials and who has access to them and how often they're rotated and such. Number 7, insecure system configuration. Then we have ungoverned usage of third-party services. Oh, yeah, that's an interesting one. Also, improper artifact integrity validation. Oh, Iman actually touched on that briefly. And then we also have insufficient logging and visibility, which is interesting because that one, I think, is also in the OWASP application top 10 as well.
Yeah, awesome.
Okay,
that's it. That's
it. Yeah, Aman, do you want to take us home?
Exactly, that concludes this episode of our AppSec Insiders podcast. We hope you have enjoyed learning about attacks on CI/CD pipeline. Please remember to tune in next time as we delve deeper in the world of application and cloud security and explore new ways to protect our digital assets. Also, we appreciate your support and engagement. If you have any topic in your mind, please don't hesitate to reach us out at AppSec Insiders at forwardsecurity.com, or our Twitter handle is FWD_SEC, or feel free to follow Forward Security on LinkedIn for the latest in application security news, other opportunities, job opportunities. Also, please consider subscribing to our podcast, and have a good one. And
there's a few upcoming events we should mention.
Go ahead, please.
I believe there is June 10th is the OWASP Pacific Northwest.
That's right.
Conference that's coming up. Yeah, it's in Portland. It's going to be a Pacific Northwest conference. This year is the first physical version of it. The conference has been going on since 2021. So this would be the third year, first year in person. Next year it's going to be in Vancouver, so keep an eye on that, and highly recommend that you check it out. Pacific Northwest is pretty beautiful. Portland's awesome. Then Jared, what else is happening that we should mention?
There's the Collision Conference happening June 26th.
We have a booth.
That's happening in Toronto. Are we returning to Collision this year?
We're returning. We have a booth. Yes, we're going to showcase our Eureka product. Yeah.
Oh, amazing. And then following that, we've got ForwardSec and AWS, the CloudSec 5-part mini-series, which I've heard very good things about. That is every Thursday at 10 a.m. PST. That's when we release the videos, starting May 18th. So set your calendars. That's less than a month from now, and it goes all the way till June 15th. And if you want to know more, if you want to get notified, you go to forwardsec.com/events. That again, that's forwardsec. You know what? Also, I shouldn't be saying forwardsec because really, this is how I read it out loud, but it's FWDSEC. Foodsec.com. Also forwardsecurity.com. They both go to the same place. /events.